Welcome to The Air Up There, a podcast about the wide world of aerospace. I'm Liz Corey, and today we're going to look at greener ways to fly.
And I'm Deja Matwire. Liz, last year, the Department of Transportation announced the goal of net zero emissions by 2050. I think that shows the FAA is really committed to building a cleaner, quieter, and more sustainable aviation system.
You're right, Deja. Alternative fuels are critical to this goal. Sustainable fuels can be used in today's fleet of planes and are produced from food waste, oils, and other sources. But what about battery-powered aircraft? Testing is going on right now.
Our first interview is with the FAA's Jim Hileman, whose job is to look at how we can fly in a more eco-friendly way. He tells our colleague, Tony Molinaro, why sustainable fuels are so important.
If you look at aviation as a whole, including airports, including ground equipment, the general aviation fleet, and then all the commercial fleet, the civil fleet, we found that 97% of the emissions, CO2 emissions from aviation are attributable to jet fuel use. It's not to say that the emissions from airports aren't important. They absolutely are, or that we shouldn't be working on general aviation fuels. Absolutely, we should. But if you really want to, reduce aviation CO2 emissions, you really got to work the jet fuel. The other things we looked at was we considered, how fuel efficient is the aircraft fleet itself. So we took a pretty deep look at that, and we actually found out that the average aircraft today is on a per passenger mile basis more efficient than a Toyota Prius hybrid. If there's only one person, the driver and the Prius. So it's really fuel efficient. And so then we also, looked at, what could we get from operational procedures, talking a lot to our colleagues at NextGen and in the ATO to think about what could be done there. And we're thinking, that the airspace is pretty darn efficient on a good weather day. So we took that into account, and then we used the aerospace forecast to look out into the future all the way out to 2050 and considered, that colorful chart, that wedge chart. We looked at, the importance of new aircraft, that the airlines are buying new aircraft, such as the types of things that we're developing through our continuous lower energy emissions and noise program, the CLEAN program, work that NASA's doing, that improvement with operational procedures. And it became very clear that if we want to bend that curve down to zero in 2050, we basically have to have 100% SAF use. We basically have to increase the use of these sustainable aviation fuels dramatically.
So we're talking about creating these new fuels. Who's doing the research and the testing, or who's going to be creating them?
There are certain companies that actually aren't doing research, they're producing fuel. So if you fly out of LAX on certain flights, you would actually have a certain amount of this HEFA fuel in the tank with you. And that's been the case since 2016, because there's an old asphalt refinery that was converted over to make HEFA fuel as well as renewable diesel. There's a number of other facilities across the country that are coming online. And these facilities are there because of investments that have been made. But beyond, doing the physical process, the conversion process, there's a lot of other work involved in the supply chain. Understanding where the feedstock is, understanding where the conversion facilities are, understanding where the airports are, how the whole system is interconnected. What we've done through our Ascent Center of Excellence is we've asked universities from different parts of the country to, work with people in their areas to develop these supply chains with an understanding of what are the local opportunities in terms of feedstocks, where are the local opportunities in terms of petroleum refineries, corn ethanol facilities, paper and pulp mills, other industrial facilities that could be repurposed or leveraged or somehow used to help in SAF production. And by distributing this work across the country, but coordinating it here at the FAA, alongside our partners at Department of Energy and Ag, we're able to get a better view of what's going on across the entire U.S.
And what will the cost be when you get a final product? Is this cost for the sustainable aviation fuel going to be more than jet fuel today, less than jet fuel? What's in it for the consumer? What's in it for the airlines to make this transition?
One of the challenges here is the price, because the price really drives a lot of things. But one of the things that we know is true is that not all of these sustainable aviation fuels, they have varying prices. And that stands to reason when you start thinking about it. So you have some things that are created from waste. So a waste is something that really doesn't have much economic value. And there's also the cost of upgrading this feedstock to a finished fuel. And that upgrading process, has a different cost depending on, are you starting from a liquid, a gas, other things. So depending on the process, it could be marginally more expensive to actually being considerably more expensive. And part of what our research is doing, the supply chain research is doing, is understanding what are the drivers making some things more expensive than others, and identifying ways that price can come down. And one of the key ways to bring price down is, and I mentioned it earlier, is leveraging existing infrastructure. If you don't have to build something, that's money you're not spending. And then also find where are the high value co-products or byproducts that could be created alongside the SAF. And so those are some of the things that we're thinking about deeply. And then we're also doing work, there's a lot of policy discussion about potential policies to support SAF production, because sometimes the price just will be more expensive than petroleum-based fuel, and we're helping to inform those discussions.
What needs to happen next? Is this 5 years away, 10 years away? At least by 2050, that's a long time away. So when do you think, we'll really see benefits?
We had a lot of discussions around, we need something more immediate in terms of something to shoot for, because putting out a number for 2050, a lot of people are retired by then. What's that even mean? So we put 3 billion gallons in 2030 as our goal. That's our mark. 3 billion gallons of SAF. And this was announced at the White House Sustainable Aviation event in September of last year. And I was really happy because at that event, Airlines for America, our domestic carriers, they said, yeah, we're going to do it too. We're with you. We're going to shoot for 3 billion gallons of SAF by 2030. And you might think, well, 3 billion, that's easy compared to 35 in 2050. I actually think it's harder, because right now we're sitting at about 5 million gallons per year. And so what this means is we have to double production every single year between now and 2030 to hit that mark.
Yes to sustainability. Now, let's hear about battery power.
Our next guest, Greg McDougall, began his airline literally on a wing and a prayer. He founded Harbour Air during the global recession in the 1980s. Since then, he's taken this British Columbia company to new heights. Our colleague Ryan Willis caught up with him and learned how Harbour Air is testing battery-powered aircraft.
The environmental aspect for us is huge. I mean, we're operating in and out of downtown locations that have evolved from being, working dirty sort of harbors to neighborhoods. And so, now we have residential neighbors all around us where we operate. So the noise is an issue in terms of us trying to mitigate our noise footprint. Also, soot and carbon and all the rest of those things. Although there are, major ships running in and out of there that do a pretty big job of that, but we're very conscious of our sort of environmental footprint in those neighborhoods, and we want to mitigate it to the greatest extent that we can with the technology available. So it was natural for us to kind of look at this, and then also being in this, as I mentioned before, a unique position of having these shorter stage lengths and type of equipment that will allow us to retrofit. The whole retrofit idea is kind of a what call it a workaround or a shortcut to get to be able to have this certified because you're not building an aircraft from the ground up that's electric. You're taking one that already exists, an airframe that already exists and has already been proven and has already, proven safety and everything else, and just basically exchanging the propulsion system. So it's a much faster pathway to get this accomplished. I think in the longer run, we will probably be using aircraft that will be built from the ground up for electric power. But this kind of gets us there in a quicker fashion.
So, Greg, was this something where you, as far as the technology that goes into retrofitting these planes, was it something that had already existed, and you just basically found some parts, on a shelf, and just plugged them into a plane? You dropped out an engine, and you just put a battery in there, that type of thing, or did you have to do some R&D in this type of endeavor?
Well, it all kind of fell into place because we were, making, I don't want to call it making noises because it's kind of the antithesis of it, but we were talking about trying to electrify aircraft, and I guess we talked about it enough that we were sought out by Magniex, which is a manufacturer of aviation electric propulsion systems. That's why they exist. They were a startup, originally out of Australia, and now they repositioned to Washington State, around the Seattle area. And they came and visited us and said, well, it looks to us like you're the perfect candidate for us to align with, because you want to be first to certify a commercial aircraft for electric flight, and we want to be the ones to first certify an electric motor to do it. So it was kind of like a 20-minute conversation where, well, let's get it done. And within about 3 months, we had the prototype sitting there ready to fly. And that's a really, really fast pace in when it comes to aerospace development. So we also, got a lot of cooperation out of Transport Canada here in Canada. They certainly were excited about the project and have been very supportive. So we were able to get the attention that was required to get permits and flight permits and all that to test it. So yeah, it's been a super positive project all the way along. We've had the odd little glitch here and there, as you're going to have whenever you're dealing with prototypes and new technology. But it's been certainly a positive thing to work with, and we definitely see it as being practical in the long run. We have a chance to actually be the first in the world to carry a paying electric, aviation passenger, which is a really big deal. And we may get beaten by somebody, but at the moment we don't see anybody close to us. So we have the chance of doing that, and that's quite exciting.
What's it like being in an electric plane? Like if I'm a passenger, am I going to notice a difference?
Yes, you will notice a difference in our planes, especially because the traditional, internal combustion engine is quite noisy. So definitely all of a sudden you're into wind noise only and some propeller noise, depending on what it's doing, but definitely quieter. And from the outside, for sure, people, don't even notice it flying over anymore because it's basically almost silent. So there's that experience in terms of the sort of the quietness of it.
So I'm sorry, when you say quieter, like if you could give me like a range of something that I can kind of.
Well, I can't cite the actual decibels. I should be able to, but they're not coming to mind at the moment. I do know them somewhere in the back of my brain there, but it's reduced by over 50% in terms of the noise, and depending on what flight configuration we're in. Takeoff, you do get a lot of propeller noise because on traditional prop driven planes, the propellers tend to go supersonic, and then they do make some noise there. But in general, like in all the flight configurations, way quieter. The other thing, of course, is anybody that drives a Tesla or a high performance electric car knows that you get instant torque So the takeoff performance is pretty dramatic, and even with the weight of the batteries as they are now, which is pretty heavy, you kind of get up and get going and climb much faster. So up to altitude faster and quieter, and in every way, it's a better experience for a passenger.
What do you see as far as the future of electric planes? Do you ever think it'll get to the point we'll see the bigger passenger planes going electric? I know that's probably a bit of a stretch, but what are your thoughts on that?
I don't think it'll be that long before we see hybrid for sure in just about every major aerospace company that is producing engines. I mean, GE, Rolls-Royce, all these people, they have hybrid programs going for sure right now, and testing and everything else. And of course, NASA's involved in this, and a whole lot of other people. So definitely that's going to happen. Then there's the whole hydrogen fuel cell development, which is really a game changer, because the amount of density of energy in hydrogen fuel cell versus batteries is pretty drastic. And so it'll allow more range and more payload if they can get that technology sorted out, which they're well on their way to doing. There are some prototypes flying today with that as well. So if you think of the hydrogen fuel cell as basically being another battery, but it's a more efficient battery. Mm-hmm. So I believe the longer haul obviously is going to take pretty drastic developments in different technologies to make it practical, but hybrid certainly will I think be well within my lifetime for a longer haul, and for shorter regional aircraft. We're right on the threshold of it. I mean, it'll be here within several years.
Do you ever see just wondering, do you ever see somehow solar being able to be part of that type of system?
Difficult, because solar, the amount of solar panels required when you're powering an aircraft, you need a lot of energy. It's a matter of drag and weight. So solar, although solar farms on the ground can produce a lot of energy, they require a lot of real estate to do that. So the real estate available on an actual aircraft is pretty small. So you're not going to get a lot from doing that, unless it's an extremely light aircraft, like some of the prototypes that have flown with almost pure solar energy. But they're not very practical for carrying people.
What are the? I guess range is the right word. What is in comparison, to your vehicles now, in comparison to a gas powered plane? What is the difference in some of the range?
Well, so that's a bit of a tricky question, because of the fact that what we're using right now in terms of batteries in our 1.0 version are batteries that were suitable for a prototype in an aerospace environment. And so what we had to do was basically get the safest, most reliable batteries available for that use, which were sort of built for space stations, and they're kind of old technology basically. And so they're heavy. They're very heavy. In fact, the aircraft takes off basically at gross weight with just a pilot and the batteries in the back. So the range on that aircraft is around a half an hour with a half an hour reserve. But that's, at full gross weight. And of course you land at gross weight as well, because you don't burn anything off like fuel, where you're getting lighter. So that gets the job done in terms of, us being able to test and prove out the technology. But where you're get into actual payloads is on our next version, which is the 2.0 version, which should have more range, more payload, and basically be into the realm of being, economically viable to actually make flights that you could charge money for, and also, pay for your direct operating expenses and everything else. So So that's where we're going in a short time, which I think is great because we're going to prove the economic viability of this along the same pathway as we are with the regulatory side on the safety side. So that's a good thing. I strongly believe that as we get through this regulatory process, the difference between today and a year or two down the road is going to be drastic in terms of what is available in terms of the energy per kilogram of weight.
So what do you see as maybe some future uses of electric vehicles?
Well, there's the whole eVTOL urban air mobility movement that I've described. It's everything from autonomous vehicles, flying around in the air, and from vertiport to vertiport downtown, and that's kind of the vision of the Jetsons vision. Right. And that's not very far away. In fact, there are companies that have vehicles right now that are capable of doing that. So there's a tremendous amount of interest and also sort of aspirational money going into the development of these vehicles. So it's going to happen. It's going to take some time, I believe, to prove it to the point where you're going to be able to have them flying on their own and landing in the middle of cities and doing all that. But it'll come, I think, a lot faster than people really probably know, because of the sort of the energy behind it, both financially and intellectually. The sky's the limit. I mean, not to it's an intentional pun, but the amount of uses and the way this will creep into people's daily lives, I think it's going to be pretty exciting over the next 10 years to see how it evolves. The biggest hurdle to all of this is there's two hurdles. I mean, one is the technology involvement, but as I alluded to earlier, it does exist today for us to be able to use it in an economical way. We're in a process of proving out the technology to the same safety level as currently exists in internal combustion engines, and that's not hard to do. Electric motors are incredibly reliable. I mean, when you think about the simplicity of them and the amount of heat that's generated in them, which is very little, they're just super simple and therefore very reliable. So that's something that's a game changer in aviation, to have propulsion systems that are not developing a lot of heat because they're not consuming a lot of fossil fuel. And extremely reliable. So that's great. But I mean, we're having to prove all of that to the regulators, and rightfully so, that it's safe, and that is a process that has not really been done before. So we're kind of charting new waters here, and everybody's learning as they go along, and of course the possibility exists for goalposts getting moved down the field, because we're not sure exactly which goalposts we're supposed to be heading through. So the trick here is to establish a process where people are going to be able to follow in our footsteps and know what the process is, because we're kind of pioneering that process. In conjunction with the regulatory authorities.
There's a lot that will go into regulating these aircraft. We spoke with a researcher at our propulsion branch at the FAA's William J. Hughes Technical Center in Atlantic City.
Dave Atwood tells our colleague, Rick Breitenfeld, a little bit about how researchers ensure safety as companies bring these new technologies to market.
The Fuels and Energy section is one of three sections within the Structures and Propulsion branch that I manage, and it addresses research in the areas of alternative fuels, electric propulsion, electrical systems. We have 11 employees that work in 4 different laboratories that conduct research in both alternative fuels and electric propulsion. The data that we generate in these labs directly supports the FAA certification service in their efforts to develop adequate means of compliance for different aircraft designs and operation policies for both existing aircraft and new aircraft or even new system designs.
Can you tell us more about the Tech Center's work right now in sustainable fuels?
Yeah, so in the fuels and energy section, we are the alternate fuels work is directly supporting efforts to prove a suitable unleaded replacement for the current leaded aviation gasoline, and that's under what's a new initiative called the EAGLE initiative. And EAGLE stands for End Aviation Gasoline Lead Emissions. So aviation gasoline is the sole remaining source of leaded fuel in the United States.
What about electric aircraft, Dave? Can you give us any insight into how the adoption of electric aircraft will occur? Some of the technical hurdles that you may need to overcome before this technology can be utilized?
Yeah, so one of the main issues, and there are several issues, but I'm going to stick with the ones that relate to aircraft performance because that's what we do. One of the main issues regarding the aircraft performance is energy storage capability on a per weight basis of the energy source, whatever the energy source is. Weight is a very important concern for aviation. It's not so much for automobiles. You know, if you need more energy in an automobile, you can add weight, and it's not as much of a penalty as it is in an aircraft. Traditional liquid hydrocarbon gasolines or jet fuels that are used, they have a very high energy content per unit of mass. Batteries, on the other hand, have a much lower energy content per unit of mass. I will add that electric motors are much more efficient than internal combustion engines. So for smaller aircraft, electrification is a high probability in the very near future, especially for shorter trips on the order of 100 miles or something like that. Of course, charging an aircraft is likely to take a lot longer than refueling an aircraft would. For mid-size aircraft or something like an air taxi application where there's frequent and repeated use, the battery technology will need to advance considerably on an energy content basis, especially for any company to see this as financially feasible. There are some companies that are looking into hydrogen fuel cell electric power systems. With hydrogen, it's not necessarily a weight issue because hydrogen is light. It's more of a volume issue, so you have to put large tanks to contain enough energy to be able to power a propulsion system. Hydrogen's typically in a gaseous state. We can use it in a liquid state where you'll get more energy content per volume. However, liquid hydrogen requires super cool temperatures or extremely high pressures, or a combination of the two. And as you can imagine, that would require unique equipment on board an aircraft, which could potentially lead to additional safety issues.
How do you think this work or your work in your section is going to translate into reality for people or even the aviation industry?
Well, the work that we do is obviously safety-related research, and we're ensuring that the new designs are not just functional but safe as well. And our data, as I mentioned before, our data, generated by our experts in our state-of-the-art labs at the Tech Center, it directly informs the development of both performance standards and certification methods of compliance for these new technologies. One of the primary uses of our data is for the FAA to understand the hazards and risks associated with these technologies and how do you mitigate those risks. And I would add that the research that we do at the Tech Center is almost always cooperative, where we bring the applicant together or the designer of the hardware together with the FAA certification folks, with the researchers. And this way, the FAA as a whole learns about the technology, learns about the safety, hazards, and risks associated with the technology. At the same time, the certification folks are teaching the applicant or the designer about the certification process, because these companies aren't always familiar with FAA certification. So it's a very beneficial arrangement for both parties. But I really want to stress that we are not doing certification testing for applicants. It's merely safety-related research. The companies do their own certification testing. These are obviously very exciting times regarding sustainable advancements in aviation, and we are expecting very significant changes in the near future that will likely continue over decades, and that will lead to improved overall environmental health. But with all new technologies, there are new safety concerns. So our researchers, and this is what we do, is we're performing the necessary research to support that safe adoption of these new technologies in the marketplace. And to me, of course, that's very exciting.
The FAA will continue to work with industry to accelerate the development of more efficient aircraft and engine technologies. The goal is a 30% improvement in fuel savings compared to today.
This work will also deliver reductions in noise and emissions, which adds to our work to improve air traffic procedures in all phases of flight. We're reducing fuel burn in taxiing, takeoff and landing operations, and we're creating new direct routes in the sky.
And Deja, that's our show. I hate to say it, but that's it. Would you like to learn more? Please go to www.faa.gov/sustainability for much more on this important topic. The Air Up There is a podcast from the Federal Aviation Administration. If you liked today's episode, remember to subscribe and please share it with someone else.
You can find the FAA on social media. We're at FAA on Facebook, Instagram, and LinkedIn, and at FAA News on Twitter and YouTube. Thanks for listening, and happy Earth Day.